was good practice. Everybody, I have failed you. And I realized how badly I have failed you. I have actually been sitting here talking to the camera for the last 45 minutes, doing a show for about 45 minutes. And I thought I was live. And I wasn't live. And I did 45 minutes of a show, not live. So with that being said, now that I am live, I've been sitting here talking for 45 minutes. I'm like, man, chat's quiet today, but I'm going to put on a show, darn it. And I did. Let me tell you, it was amazing. No one's ever going to see it. I even taught a full lesson on Kubernetes. This is awful. I was even sharing links. So, what's going on, Luca? I was even sharing links. I was doing the whole thing, a full production, and I wasn't live. So here's what we're going to do. I'm going to take a 5-minute break. I'm going to let everybody know I made a mistake, that we are, in fact, live. I'll put on some No Man's Sky music, get everybody back in here, and then what we're going to do is we'll do it again, and we'll do it live. Sorry for the confusion, everyone. We'll be back in 5 minutes. Yeah, I'm shaking off the rust, guys. Haven't done this in a long time. When we come back, fun with containers and demons, Kubernetes, coffee, and games. I'll see y'all back here in a little bit.
Embrace the journey, where each moment turns into a cherished memory. Your membership is more than just a card. It's your gateway to extraordinary experiences. With the AAA app, discover savings and hidden gems, from dining to travel to hotel stays. Your membership is your companion, with the partner you trust. AAA, we're always with you.
All right, everybody. We're back, and I have to tell you, I really thought, I really thought that I was live for the last 45 minutes. I did a full 45-minute show to no one. And I was like, chat's quiet today, but darn it, we're going to do a good show. And it was awesome. It was, you'll never see it. No, man, I was sitting here performing for myself. It was amazing. It was great. It was everything I thought it would be. If I ever had to do this again with no viewers, I was prepared. It was a great show. In any particular case, guys, welcome back. Good to see you all. Tylerium Gaming, good to see you, man. Thank you for being here. Even when I was performing for myself, you were there like a true friend. Appreciate you, buddy. Luca P., good to see you all the way from Croatia. Thank you for tuning in, man. Hope you're doing well. Average Panda, what's going on? Good to see you. Welcome to the show. Good to have you here. Karmic Canine. Thank you all so much for that. You remember, back in the day, those of you who were with me back in the old school No Man's Sky days, we used to do something called a hashtag LikeSpike, which you would click the like button and type hashtag LikeSpike in the chat. That lets YouTube know that people like me. I like it when people like me. That being said, I got a lot to get into in today's podcast. Today, we're going to have fun with containers and daemons. And I understand that some more technically inclined people would be thinking, is he talking about daemons, processes? No, I'm talking about demons. We're going to slay demons later today. It's going to be great. It's going to be Lazy Bye, good to see you. I know, I'm so sorry. Everybody who waited for me, I'm so sorry. We're here. So that's what we're going to be getting into today. We're going to be talking about containers. We're going to talk about containerization, Kubernetes. We're going to do that tutorial on the front side. And now that I've had practice doing it, the second time I do it, it's going to be 10 times worse. That's fine. That's normal. But before we get into all of that, I wanted to remind you all that this is a podcast. It's going to be a non-regular podcast. It will happen when I can do it. My hope is to keep the shows under 3 hours. I don't expect these to get long. And we're going to be talking about just life, okay? Particularly my experience as someone who is involved in foster care, as a foster parent. We'll talk about that once in a while, obviously with full respect in regards to the children. I cannot talk details until after we adopt some kiddos. And then I will let them tell the story if they so desire. It's up to them. But that's basically, there is limitations as to what we could talk about. So just be aware, I can't get into details. I can't talk about kids' names. They can't be on camera. You're not going to see them. In fact, I put the curtain on the door and I lock it. That's 2 ways of protection to make sure little kiddos don't come running in here. So the stream formats are going to be much shorter than what you guys were used to from me in the past. So get used to that. And I'm not going to be able to talk as candidly as I'd like. But I want to get into the first topic of today's show. I talked about this at length yesterday. So if you saw the podcast from yesterday, you already know the whole story and everything that I can talk about, because I am significantly limited in what I can say. Okay. So with that being said, if you want the full explanation as to what's going on, the total story about what's happening with the foster care crisis here in West Virginia, take a look at the previous episode of the podcast. It's called Life Update, Kubernetes, Coffee, and Games. Be sure to take a look at that. That is the previous episode of the podcast. So with that being said, let's get into very briefly what our fundraiser is all about. And if you are a streamer, Tylerium Gaming, I am asking for your help. I know the gaming community is really good at raising funds, and I need to activate some of y'all for this. And I'm going to read this so as not to open myself up to liability. I have to make sure that we're very, very, very clear with what I say, and I can't talk too much about the details. So I would definitely like to activate any streamer out there, anyone who creates content. Please consider helping spread the word about this particular GoFundMe. And I would love it if we could get a good, strong fundraising drive going. That is just a big ask. I know it's a big ask and on short notice, but I really want to get this out here. So this is a GoFundMe, and this is Help Us Fight for a Child's Right to Safety and Family. We are reaching out for support in an urgent legal battle to protect a vulnerable child who has been failed by the system. This child, who was once in our care and remains deeply loved by our family, has suffered mistreatment, neglect, and unnecessary separation from those who care for her most. From the moment she entered our lives, she made it clear that she wanted to be part of our family. She calls us mom and dad and has repeatedly expressed her deep desire to belong with us permanently. Despite this, the system has ignored her wishes and placed barriers between us and her, denying her the stability, love, and security she so richly deserves. Over the past year, we have fought tirelessly to ensure that she is safe, heard, and protected. Unfortunately, due to serious failures within the foster care system, she has endured documented abuse in placements that should have protected her. Despite overwhelming evidence, she was placed in harm's way, and now she has been cut off from us entirely without legal justification, which is a direct violation of her rights. West Virginia has a foster child bill of rights. That is the right violations that I am referring to specifically. We have secured legal representation and are taking action to challenge these decisions in court, and our goal is to restore her right to maintain safe and meaningful relationships with those who love and support her, give her the opportunity to have her voice heard in court, and hold accountable those who have failed her to protect her. Ensure she has a chance to grow up in a stable, loving home, one she has already chosen. And then finally, just a kind of legal battles of this nature are costly. They are very expensive. They're very complicated. And we cannot do this alone. So your donation will help cover attorney fees and legal filings to fight for her right to family, expert testimony and court costs necessary to prove her case, and then investigative resources to ensure her well-being is prioritized. So every dollar raised brings us one step closer to giving this child the home and future she longs for. If you believe that every child deserves safety, love, and a voice of their own in their own future, please consider donating and sharing this campaign. Thank you for standing with us in this fight for what is right, and your support means everything. With gratitude, Timothy and Rebecca, and we posted an update today. We've had 24 hours, more than 24 hours now, and we hit 25% of our goal and more, and then some. We're at 27% now. So, thanks everybody. Big shout out to our recent donation from Cast Jewel. Thank you so much for that. So thank you all so much for helping us hit 25% of our funding goal. This is incredible. While raising funds and awareness about foster care crisis in West Virginia, I have decided to come back into doing some content creation. So you guys are watching that right now. You can check it out here. We're going to spend more time talking about this fundraiser and the foster care system here in West Virginia and what you could do to help out in your neck of the woods. Now, there's also a fun little picture here for those of you who might remember Maggie Moo. Or Moogie Moo, that's my mom. on the left there, and of course our child there in between my mom and Tanantha, of course. So we're this was 4th of July. We took this picture. We took her to go see a parade. It was a lot of fun. So there it is, everybody. That is the fundraiser. Again, I'm just going to post the link again. If you want to support or share, either way or both, that would be fantastic. And the big thing that I want to point out here is that while this is a fundraiser that is supporting one child, there are many children who are going through very similar circumstances right now in West Virginia's foster care system. We talked about this in detail yesterday, so be sure to take a look at yesterday's podcast for the full explanation as to the severity of the problem here in West Virginia. It is tragic, it is significant, it is far-reaching. There are major, major problems with the foster care crisis here in West Virginia, and it is a crisis. There are many children who are going through very similar problems as our particular child. While she has, one thing that people ask, well, why is this one child so much specialer than the others? And well, the others didn't come to my house. This one did. And we don't give up on our kids. We fight for our kids as hard as we can, and we never give up. One big thing that you'll find is that when you're in foster care or child welfare, what you'll find is that a lot of the children are big fans of Lilo and Stitch. They're very big fans of Lilo and Stitch. And the reason why is because they love that word Ohana. And Ohana, means family, and family means no one left behind. Well, this child is part of our Ohana, and we're not going to leave her behind. That's the only reason why we're pointing the finger at her. She was here with us in our family. She wants our family. We want her to be a part of our family forever and ever, and we love her to death. But there are a bunch of other kids who need help. So our hope is that by helping this child, we can raise awareness to the problems in foster care, specifically in West Virginia, and we can put more eyes on this and maybe even begin legal defense funds for even more children. Because right now, these kids, they want family, they desire family, but they're being kept from family. And even in this situation where she has family, they are being taken away from it, and there is no good explanation as to why. And so if we put a spotlight on this particular child, then my hope is that we can then bring to light the other troubles and issues that are happening throughout the state and in your neck of the woods. So one of the things I want to also just remind you all is that foster care isn't just a West Virginia problem. It's happening in communities throughout the world and throughout the country here in the United States. We need to be aware of what's happening with these kids, and we need to make sure that we have oversight and eyes on the problem. I mentioned yesterday that one of the legal tools that they give us, what they actually train us on, is that if you are trying to advocate for a child who's coming out of an abusive situation, you can sit there and scream at the top of your lungs that they're hurting the kids. But some judges won't listen to you. So what you do instead is you say, hey, they're hurting their animals. Animal cruelty laws are far more strict and severe than child abuse in some states. So we actually do that. And it's one of those things where we talk about, hey, how many times have you heard Sarah McLachlan singing In the Arms of an Angel? A lot. It's a meme. We joke about it. How often do you hear about children in similar circumstances who do need help, who don't have family, who don't have parents for whatever reason? Well, you never hear about them. I don't see any ads about it, and I live in a state with a major crisis. So it's one of those things that we really need to start shedding a light on, and I want I want to thank you all for being part of that and for hearing the story. And if you want to know more about it, tune into yesterday's episode. It's called Life Update, Kubernetes, Coffee, and Games. You can check that out there. All right, everybody. Thank you so much for allowing me an opportunity to talk about right now my big interest and my big, hey, let's talk about this. And now I'm going to change gears. We're going to change gears. We're going to start with the business end of the stream first. The business end of the stream. And that is, of course, we're going to talk about Kubernetes and containers. We're going to talk about containerization. We're going to talk about why Kubernetes, what is Kubernetes, and we're just going to jump into all of that fun stuff. Karmic, thank you so much. Yeah, I hope the GoFundMe goes well as well. And remember, if you can't contribute, the least you could do is share. And sharing is the big thing, because if we share the story, more people know there's a problem. And people must know, hey, there is a problem, and we need to fix this. So, yes, thank you, Karmic K9. I hope it goes well as well. Do not underestimate the power of your share. Also, for those of you who are in our Discord, I did put in the general discussion a poster that you can print and you can post it anywhere. And it has a QR code that'll lead people to this GoFundMe page. So if you want to get a hold of that poster and start printing them out, go for it. I would appreciate that so much. Hang it up. That's something that you could do as well. Awesome, everybody. Now, let's get into the business side of the house. We're going to get into Kubernetes. Now, when we jump into Kubernetes, I want to go ahead and just do a quick little shout out and thank you to Alta 3 Research, because Alta 3 Research is providing for us the infrastructure that we're using to produce this technical content. They provide infrastructure as a service for learning. And today we're going to be running labs and examples out of our product that I'm very proud of. It's called Crush the CCAT Exam. And it is an awesome product. I love it very, very much. And I'm going to go ahead and tell you how you can get there. If you head on down to alta3.com, you'll be taken to a page that looks a little bit like this. I'm going to go ahead and put a link here in the chat for you all. There it is, alta3.com. You get to a page that looks a little bit like this. And if you want to participate in self-paced learning and you want to join us and maybe run some of the examples, all you really need is some good Linux CLI experience. If you can handle your way through the Linux command line interface, you know how to use Vim or Nano, really Vim. If you know how to use Vim and all that good stuff, right, then you would be able to jump on in and use this particular course to learn all things Kubernetes for $45. It is the best deal, period. Or maybe you might be interested in Crush the EX200. Maybe you do not have the Linux command line proficiency and you want it. Well, we have a brand new product. It's called Crush the EX200 Exam. You can take a look and see what this is. Basically, it's a real exam simulation. You'll get some AI coaching, and you'll get an environment for as long as you need it. And if you click this little link here, I'm ready to crush it. You can see that there's a 3-day trial. You get access to the environment for 3 days for $3. A monthly cost, $39. Or if you want to have access to a learning environment for the entire year, that's $300. Pretty good deal, and you get all the course material, and you can practice for as much as you want as you are learning Linux. Really good product. Now, what we're doing today is we're jumping into Kubernetes, and pretty much you should already know your way around Linux in order to take this particular course that I'm going to be sharing with you today. So in order to gain access to that particular course, you would go to Courses and then search Courses, and you would select Kubernetes, and here you find Crush the CCAT. If you click Crush the CCAT, you can click on Self-Paced. And under Self-Paced, you can see we have self-paced learning at your own speed. How about that? Enroll now for just $45. Here's what you get for $45. You're going to get an environment for 3 days. It is a full practice mock exam that you can play around with for 3 days. you're going to get 4 virtual machines. One for your beachhead workstation, you'll get one that's a controller, and then you'll get 2 worker nodes. That's the reason why this costs a little bit more than the EX200. It's a lot more infrastructure in place. Then you get this lovely set of labs where we will help you get Kubernetes up and running with deploying Kubernetes using Ansible. We actually demonstrated this yesterday. And then you'll have mock exam tasks where we will set up the lab and get you up and rolling, and you can basically choose your own difficulty. So if you already know a thing or two about Kubernetes, you can go ahead and then run through this lab and try to do it without any help. But maybe you need help. Well, don't worry. We have hints available for you, or we have answers. And in some cases, we have the genius solution where we tell you how you could do it really fast. And we break it down in a way to explain the entire command that we're using and the theory behind why it works and why you'll get the correct answer doing our genius solution. In any particular case, this is a full package, and it also comes complete with video tutorials hosted by none other than me. So then there's that. So how about that? That's pretty good. That's a nice full package. So if you know nothing about Kubernetes, then you get all of the video tutorials as well for each and every single one of these labs. You'll get to have yours truly teach you the content and show you the way. So it's a very, very good product. I recommend you check it out. For $45, you get all of that. All you got to do is click Start Today on this particular page, and I will put the link into the chat directly to the course. So if you're interested in following along with me and running these procedures alongside me, go ahead and click Start Today. Get yourself onto that 72-hour environment and pop into some Kubernetes learning. All right. With all that being said and done, thanks again to Alta 3 for allowing us to use their facility, their infrastructure, for the purpose of this content. I've held on my end of the bargain. Now let's go ahead and let's get into some Kubernetes learning. Coffee was included on the title of the podcast. Let's do it. Now, when we're getting into Kubernetes, yesterday we actually got Kubernetes up and running. So we have our nodes up and running, and we did this using something called Kubernetes the Alta 3 way. Now, one thing I did not do yesterday is I did not show you Kubernetes the Alta 3 way, and I want to share that with you today. So here is our GitHub repository for Kubernetes the Alta 3 way. This is open source. You can use this if you so desire. Feel free to come on into the GitHub page, and I'll post a link to this now. And you can star and fork this if you so desire. A lot of people use Kubernetes the Alta 3 way to power their own learning environments. So maybe you don't want to rent the infrastructure. You want to build it yourself on your own environment. You could do that using this playbook, assuming, of course, that you have 4 virtual machines named Node 1, Node 2, Controller, and BCHD, respectively. This should work, and they're all in the same network, all in the same subnet. This should work with minor retooling. So with that being said, this is available for you to use if you so desire it. Now, what Kubernetes Alta 3 way is a Ansible playbook. So we talked about Ansible a little bit yesterday, but if you're just tuning in now for the first time and you want to know more about how we deploy Kubernetes, we did this yesterday. This is the playbook that we run, and if you're familiar with Ansible, you would know that we're calling out roles, which are their own collection of tasks. So if you want to see how we install etcd, for example, you could take a look at the roles etcd tasks main.yaml page, and here you see all of the tasks that we take to get etcd installed, up, and running. So be sure to take a look at that if you're interested in how we initialize Kubernetes. This ensures that whenever we run a class, all we do is run the playbook. It works every single time, consistently, without fail or issue. And if we ever have to troubleshoot a major problem, I can stay focused on the course content, run the playbook again. That'll set us back to where we need to be, and then the student can continue on their learning journey without much of a disruption. Ansible, as our method of installing Kubernetes the Alta 3-way, has been wonderful. It gets the whole job done very quickly without any major problems. So, with that being said, that's Kubernetes the Alta 3-way. Let's get into a brief review of what we learned yesterday. Now, what we learned yesterday was we started talking about containers. Today, we were going to be having fun with containers and demons. And by demons, I don't mean daemons. I mean, we're actually going to be fighting actual demons in Diablo 4. But that's later on in the stream. So before we get to the fun part, let's talk about containers. Now, we started talking about containers. And when we started talking about containers, we basically defined what a container is. And if you were here yesterday, you would know that my definition for a container is vastly different than anything you've probably heard before. But a container, if we're going to brass tacks this, is just define container as exactly what it is nothing more than an isolated process. That's all a container is. It's an isolated process. That's it. So how do we get there? Well, an isolated process. This is a process that is isolated along 7 namespaces of isolation. We covered these in detail yesterday, so be sure to check out yesterday's episode. We're just going to quickly review what we learned. But we're separating or isolating this process from any other process on your host system by way of individualized cgroup, meaning resource protection, network, so they each get their own IP address and network stack, mount point, so they get their own file system. IPC, which is inter-process communication. So what that means is that traditionally your processes that are running on a host system, they're able to talk to other processes through the kernel space directly, which is really fast, like super fast. All right. But with the container, we are not allowing that. We're going to prevent the containerized process from communicating with other processes on the node. Now, this is designed that way for the sake of preventing things like conflicts, where one application might cause a problem with another application, etc. So what we're instead going to do is that instead of having that process talk to the other process over IPC, we're going to talk over network. Now, talking over network is a lot slower than through the kernel space. But that does prevent the conflicts from occurring, and it's still fast enough where most users probably would not notice too much of a performance downgrade. If there is a performance issue, we could fix it by putting multiple containers on the same pod, but we'll talk about when and why we do that later on. So just be aware, IPC is inter-process communication, where a process talks to another via kernel, via the kernel space. Wonderful. Now, after that, the next thing we're going to go ahead and talk about is we're going to talk about user IDs and group IDs. Wonderful. User IDs and group IDs. What are these? You know, users and groups, right? We're going to have different users and groups available to the container than the host. So that way the container isn't using users that have permissions on the actual host itself, but instead we're using users that only have permissions within the container itself, which is wonderful. The next namespace of isolation is going to be process IDs. That is process IDs, so we won't be able to view the other processes running on the host. And then finally, we are going to have UTS, which is a Unix time-sharing service. This is a fancy word for host name and NIS domain name. Okay. So that is what UTS is. So those are our 7 namespaces of isolation. Now, a common question that I get is, okay, so what's the difference between a virtual machine and a container? Answer? Here's my answer. Stop it! The two are nothing alike. Do not compare a container with a virtual machine. Why? Well, virtual machines will virtualize a kernel space. Containers do not. They are fundamentally different. There is no virtualization component in a container whatsoever. The only thing we've done is we provided 7 namespaces of isolation, which we can do resource protection, get it its own network, give it a mount file system and its own mount points, give it its own IPC namespace, give it its own users and group IDs and process IDs, right? But we're not virtualizing a kernel space at all. Stop trying to compare containers with a virtual machine. It's bad. Don't do it. Now, the next thing, now that we've had a chance to talk about containers and remind everybody why a container, the next thing to talk about containers is just a brief reminder that containers allow us to package up individual business functions. I see my face is in the way. Into a microservice architecture. Wonderful. Before I go any further, take a moment to screenshot this, if you so desire. Of course, naturally, you can watch the archive of the podcast that will be available to you on YouTube. I'll also be sharing this on my LinkedIn page and on Discord, so you can find the archived versions of the podcast there. So with that being done, with all that being said, we've had a chance to kind of start breaking out into what is a container. But now I open up a whole new can of worms, and that's this. Containers allow us to package up individual business functions into microservice architecture, misspelled horribly. Architecture. Yeah, there we go. We got there. What's that about? What are microservices about? All right, let me go ahead and let's clear the screen here. So traditionally, when we write our applications, a long time ago, we would write our applications in something that was called a monolith. And a monolith just means that all code is written as a single unit and executable. So you would imagine, for example, if I'm playing an old school video game, I would just start it up and all the code that was needed for that video game to run back in the day was on that one single executable. And so if I hit a critical error or a fault, the whole application would come crashing down and I would have to then restart the game, and hopefully the last save wasn't too long ago, right? I'm sure you all remember that. That's how things were. You run into an error and it just bugged the whole thing and the whole thing comes crashing down, right? Well, today, we don't write applications that way. Not like we're used to. Sure, for example, if we were to talk about Diablo IV, which we're going to play Diablo IV later today, unless you have a better idea. But if you were talking about something like Diablo IV, that game, its server side or its web services part of the application is run on Kubernetes. What? Yeah, it's Kubernetes, guys. So if I'm thinking about Diablo IV, I have to understand that we're working against a microservice architecture. So what does that mean? Well, let's get into microservices. So when you have Diablo 4, naturally you have a client-side application. And that client-side application is installed on your computer. So you launch that executable, you're playing a game, and it feels like you're playing an old-school game where it's all on one client. And then you get confused as to why you require an internet connection in order to play the game. Well, here's the reason why. In order to offload a lot of the processing from your computer to run the game with all the fun little features that you wanted to have, we're going to run some of that processing on Blizzard's machines. Now, a lot of this is the back-end data pushing processing, okay? A lot of this is also designed to more or less separate server-side client information from client-side information. We don't want you to have your character files, for example, saved locally, right? And the reason for that is to prevent cheating, among other things. But a lot of what Diablo is, believe it or not, it's a social service. You actually hang out with other players, whether you mean to or not. You can be part of a guild. You have your friends and social stuff. You've got achievements that you can unlock and do, which needs to be held server side. You've got the online store, and you have access to all of your items. And all those items have to be stored server side as well. That cannot be stored client side. Again, for cheating concerns. And so we need to get connected with all of those services in order for the game to operate. So you can't just turn on the game and play it, because everything that's saved about your character, what you're doing, where you're at, all of that is stored server-side. Now, when we have an application that is microserviced, think about something like an online store. Right? So we have an online store, and there's different parts and components to that online store. A microservice is an application in which all individual business functions, and this is a big deal, are packaged separately into containers. Which means that one part of your application is in its own little container, and another part of an application is in its own little container. So if I think about a simple little online store, I probably end up with something like at least 12 services, at least 12 microservices or 12 containers. Because I need to think about, well, I got to have a catalog. The catalog service is a business function. It's going to have its own container. I'm going to have an ad service. I'm going to run ads to try to get you to buy more stuff. So I'm going to have an ad service. I'm going to have a recommendation service based on what you've done before, what you've bought before, what you're looking at. I'm going to recommend other products to make sure you find what you're looking for so you buy stuff, because that's what we do on stores. Then I'm probably going to have some type of payment processing service, because you buy stuff, I want your money. I'm going to need a cart. That's another one. Then I'm going to probably need some type of way of handling all the redirections and just some sort of front-end proxy. That's its own service. I'm going to need probably something to handle shipping, right? So I'm going to have some type of shipping service as well, and a bunch of other services. At the end of the day, you probably need about 12 different services for a basic online store. You know, a place where you could buy boots, socks, belts, purses, you know, that kind of store. Point is, so you're going to need up about 12 different services. So each and every single one of those business functions would exist as a separate container. Cool. I like that. I like that a lot. But why? What's the point of this? What do I get from this? Because this sounds like we're just making something very, very complicated. Well, let's go back to the Diablo IV example. What's very common is that Diablo IV needs to push an update. Most of its updates are purely server-side. They don't hit your client. They can push to production several times a day, and they do. And you don't even notice. You don't even realize that they updated their game. You have no clue. They're able to achieve this because of a microservice architecture. They're able to achieve this because of Kubernetes. They're able to achieve this because we're no longer writing our code as a monolith, but rather we're writing our code as a microservice. So here's what you get. Let's remind ourselves, what is Kubernetes, everybody? Kubernetes is a container orchestrator. Okay, it is not a manager. And we'll talk about that later, but it is a container orchestrator. That's what Kubernetes is. It orchestrates its containers, and it manages something called pods. That's a whole other thing. We'll talk about pods later. Question from the chat. This may be a bit off topic or ahead, but does that mean you can get containers to communicate when isolated, like in a cluster? Well, yes. Remember that containers could talk to other processes, other containerized processes via network. So they will establish network communications between containers. But when we get into defining a pod, you'll discover there is a way in which I can get a container to talk to another container via IPC. We'll talk about that. So yeah, we're going to get these containers talking to one another over network, okay? But if I need to speed things up and I want to get IPC happening between two containers, we can do that with a pod. We'll talk about how to do that later today. So that's coming. Good question. So with that being said, we have a container orchestrator, not a manager. Kubernetes could care less about what's happening on your containers. It's not interested in what's happening on your containers. It does not initialize containers. It does not stop them. It does not restart. It doesn't do any of that. That's not its job. It is a container orchestrator. So if I want to go ahead and define Kubernetes a little bit more, what is Kubernetes doing? It is scheduling containerized workloads or containers across a pool of nodes to deploy a whole application Yeah, why not? I'll just put a period there. I like that. Nice. All right, scheduling containerized workloads across a pool of nodes to deploy a whole application. A pool of nodes. That's a fun little term. What is that? That's a cluster. That's our pool of nodes. And your nodes can be made up of virtual machines or physical machines. Perfectly fine. The node, just to define that term real fast, is the machine which provides the physical resources to run containers. Okay? That's a node. So we got a pool of nodes. We got a pool of machines. And Kubernetes is going to help us deploy our microservices across that pool of nodes. Now, why? Why? That's the next question. I get why? Why are we doing this? There's a lot of people who don't know Kubernetes very well. They're very condescending about Kubernetes. I've seen entire 2-3 hour long presentations about why Kubernetes is bad. And it's usually based on the fact that there are people out there who still don't understand it, how it works, why it works, and they don't want to change, and they don't want to adopt a new philosophy. Because the fact of the matter is this, and I'm going to tell a story. And while I was at GDC 2017 or 2018, one of those years, I went to GDC. You guys might remember this. And I watched a whole presentation on Kubernetes. And the individual who was giving that was Gavin Average. You guys know Gavin Average. He played a couple games with us. He's a good, smart guy. Okay? So Gavin Average is sitting there. He's giving this. This is how I met him. And he taught me or introduced me to Kubernetes, and we became friends after that. Gavin Average, really good guy. Okay, so after that, when I started teaching Kubernetes years ago, I called up Gavin Average and I said, hey, I'm getting ready to go teach Kubernetes. What is the most important thing that I can tell my students? And he goes, oh, that's easy. Okay. Don't. What? Yeah, just don't. Just don't Kubernetes. Oh, okay. Thanks. Yeah, no problem. Just don't. And I said, okay, hold up, bud. People are using Kubernetes. Everybody's moving to Kubernetes. Like Netflix, Google, AWS, everyone's doing it. What do you mean don't? And he goes, it's simple. There are too many people out there who are unwilling to learn and unwilling to change their ways when it comes to managing their web services. And as a result, they end up reinventing the wheel or refusing to use Kubernetes correctly, and they end up creating problems for themselves, which then I have to solve for them, but they never listen to me anyways. And he was a product manager of Azure Kubernetes, so yeah. So he had to deal with these problems. He was very frustrated, and he told me a few stories about what he was dealing with. And so the problem that we end up having is that, okay, now we're deploying software in a way that is wholly different than what we're used to doing. It's philosophically, diametrically opposed to anything and everything we've ever done in IT up till now, and we got to get everybody on board. So this why is typically associated with a concern about complexity and philosophical differences. So in order for me to more or less say, hey, okay, we're dealing with Kubernetes. We need to do this. What do I get out of it? Because if I'm going to make my dev team change the way they do business forever, I need to give them the reason why. So why? What do we get out of this? Well, here are the key features from using microservices in Kubernetes. Okay, here we go. Number one, failover. That's an easy one. Oh, wait, hold on. I need to define another term. Let me define one more term, then we'll get into why. One more term, replicas. The thing about this is that we are going to have the ability to deploy replicas or copies of the same container. Basically, we have copies of the same container. And what we're going to do is we're going to use load balancing. We're going to use load balancing to distribute traffic across those containers. Okay? Very important that we know and understand and recognize what a replica is and why we're doing this. In order for us to talk about the benefits of Kubernetes, you need to understand replicas. So you have a container. I'm going to create a bunch of those. Let's say 3. So what happens when one of my containers die or has a problem? We mentioned earlier with a monolith that if I had a critical fault, I'm playing my video game, I'm playing solitaire or whatever, and I had a critical error, the whole application comes crashing down. And what do I have to do? I have to relaunch the game and pray that I saved the game recently, right? We have all done that. As gamers, we understand and we know this. So all code is written as a single unit, executable. If I have a major critical error, the whole thing comes crashing down. Unless I have incredibly good error handling, which is done poorly pretty much everywhere. Okay? But now I have copies of the same functions, but they are existing in their own containerized packages, and I have copies of them. So if I'm interacting with one container and we hit a critical error, does it bring the whole application down? No, it does not. Only that one little container went down. But then I can redirect that user to another container, which is an exact copy of the one I was just on, run the operation, and it will work. It's the same thing. I just made a copy of it. And I'll get back what it was I was trying to get from the service. Or if I was posting something or I was doing something, it would work. So that is what replicas is doing for us. So now that we know all that, okay, there we go. We defined replicas. Let's talk about why. First thing, failover. What I just talked about, right? We get failover. If one container fails, just switch to another. Awesome. Easy day. Next one, self-healing. Self-healing is a really fancy term, And it doesn't mean what it implies at all. But let's say, for example, you have a container that does fail, and now it's dead. Well, Kubernetes has something called a liveness probe, and a liveness probe is going to say, hey, are you all right? Like every once in a while. And if I don't get an answer back, or I get an answer back that says, hey, I have a problem, right? Kubernetes will then restart that container. Well, it doesn't restart the container. No, that's not what happens. No, it doesn't restart the container. And what it does is it brutally murders the container that's busted. It's quite visceral, really. And then it creates a whole new container. Oh, nice. Wonderful. We call that self-healing. And no, it feels like we're not, killing services and then building new ones, but we are definitely killing services and building new ones. That's how we heal. We just part ways with the old and we make the new. It's wonderful. So self-healing, there we go. Okay, that's the next one. Next one. It gives us the ability to scale. Scaling is now handled. Scaling is now going to be handled appropriately. Because think about what we're doing. Each and every single one of those containers has something called a C group isolation namespace. Namespace of isolation, okay? That's what it is. And that enables me to request resources and limit resources. What's going on, Captain Admin? Good to see you. That enables us to do those things. So if I'm able to scale my resources based on the number of replicas I have currently running, then that means that as demand increases on a particular endpoint, I can then build more pods. I can add more containers that would give more resources towards that endpoint. So now I could scale up and down, or really out and in, I should say, my resources dynamically based on real-time demand. We actually have a resource called a horizontal pod autoscaler. And that horizontal pod autoscaler is what enables that automatic scaling out and in. It's great stuff. So scaling is now possible thanks to the fact that we have microservices and we have replicas. So we can scale out our resources. Now think about this real quick. Back in the day, if we were back on the monolith, if we went back to the monolith where all code is written as a single unit executable, all right, back in those days, and I was hosting a web service off of that monolithic application, everybody's connecting to the same machine, to the same client that's running on that machine. And then all of a sudden, everybody loves my product, and everybody wants a piece of it. Okay, this happened not too long ago. There was this website out. I forgot what it was about, but it was a fan-made website that was like a whole Wikipedia for Lost Ark. And it had everything from class build guides to maps and like locations of all the Makoko seeds. And it had everything. Okay, it had everything. And everybody was on it. Everyone was on it. It was built as a monolith. And when everybody started connecting to this service, it ended up needing more resources than what the web service provider had. And so it basically killed the whole website several times. They were constantly rebooting it, but there was so much demand for the website that it couldn't hold on. So they had to do a whole infrastructure change. What was that infrastructure change? They reproduced the whole website as a microservice, and everyone was wondering why it took them so long to do. Strangling a monolith is not easy work. That's hard work. Takes some time. Now, luckily, it was a basic website, so it wasn't basic. It was actually kind of cool. It was a neat website. But it did take time for them to strangle that monolith, and that's why it took them about a month and a half, about 6 weeks, to get the whole job done and redeploy it as a microservice. And it performed exceptionally better, and they were able to scale out the resources on a microservice to microservice level, which made them far more efficient without needing to actually buy more machines. So if we're dealing with a monolith, what we have to do in the event that all this demand comes in to my web service, I have to turn the machine off, which leads to downtime, which nobody likes, and then add more memory and more CPU to the machine. Turn it back on and do it all over again. Well, that's not good. That's not fun. I don't like that. So instead what we could do is we could scale out. So imagine scaling out. I can add more nodes or containers. And I'll hide my face here in a minute so you can screenshot that. We can add more nodes or containers. We can also remove nodes and containers on demand if we so desire it. So when you add a machine to your pool of nodes, do you have downtime? No, you do not. No downtime whatsoever. If you remove a node from your pool of nodes, from your cluster, do you have downtime? No, you do not. You can safely evict all of the workloads on that particular node, move them somewhere else with no outage because, well, we're replicating all of our endpoints. So there's no outage, no issues whatsoever. So now I can add resources and remove resources at will. Now, we are going to make a lot of video game references because I understand my audience. Who remembers back with New World? Yeah, New World was fun. They had a problem. Now, they were running microservices. New World and its server-side applications are a microserviced application. It's one of the first games to ever be microserviced to that degree, period. But the way that they built their server tech was very archaic, very old school, and it was a product of the fact that originally New World was going to be your traditional survival sandbox game. It was going to be along the same lines as something like an Atlas or Conan Exiles. So they built the server technology with that in mind. And then after a while, they began saying, well, let's make this more massive and let's do this whole other thing where it's going to be like a full-fledged MMO. And we're going to make it more theme parky and we're going to do some of this other stuff to it. So they never changed the server design. So the servers could only have about, I think at the time, 2,000 active concurrent players. Well, on day one, they had over 2 million players trying to play at the same time. Oh. Over 2 million people trying to connect to this web service at the same time. They didn't have enough servers. Now, you might think to yourself, well, why don't they just make more servers? Well, sure, you could do that. Let's just make more servers for this 2 million players, right? But the thing is that you and I both know that in a couple of weeks or a month, maybe a month and a half, player count's going to drop down to a couple 100,000 if I'm lucky. I don't need to support 2 million concurrent players over the life of that particular game, and so I'm not going to. You're just going to have to wait 6 hours in a queue. Yeah, we all did it. But we did. All right. So we ended up waiting 6 hours in the queue. Hi. So as we're waiting 6 hours in the queue, and everybody gets mad and upset, and they leave the game anyways because of it. It's an awful experience. And no matter how you slice it with that old way of deploying servers, which is a very monolithic philosophy, you're going to have these problems. So now what are people doing? Well, now we're doing something called serverless. And if you're familiar with Kubernetes, you might know about something called Knative, which is serverless Kubernetes technologies, which is all about scaling stateless services for an unspecified amount of demand. And you notice that a lot of video games are going that way. So back to Diablo IV, they utilize a serverless method of deploying their servers. There's still a server's there, but the user has no concept of the server. It's like a mega server, if you will. We don't even think about region. So if I am on the East Coast and I have a friend on the West Coast and we both want to play Diablo IV together, I don't have to have them create a character in my region or in my data center. No. We could play together regardless of where we live in the world, and it'll work just fine. And that is because we're using serverless technologies and we're using microservices, and we're able to scale out on demand, not just more nodes, but also more containers. So now I can play with anybody from across the world on the same server. Now, does that make for a very good persistent MMO experience? Not for a sandbox, but for a theme park? Oh, yeah. For a theme park MMO, you bet. And in fact, you'd probably have noticed that Final Fantasy XIV, for example, has been moving towards this concept of a mega server, and they're doing it bit by bit, little by little. Eventually, they're going to have all of their servers on the same mega server. I think that's what they're shooting for. That takes time because they have to basically rebuild the entire server architecture to make that happen. And they don't want to disrupt their current player base, right? But that's where they're headed. They're going that direction, and they should. So that's what else we get. Wonderful. And then finally, the last thing I want to talk about is the ability to push to production several times a day. And we do this through something called deployments. Now, deployments give us staged rollouts. And this results in zero downtime. Zero downtime updates. Wonderful. So what's this about? Well, now that we have had a chance to talk about stability, we have an outage for scaling. We can have an outage for if a container dies. But we have the ability to fail over not only from node to node, but container to container if need be. But now we can avoid downtime from pushing to production because since everything is microserviced, I'm only going to be updating a specific teeny tiny little business function of my overall application. Oh, well, that's kind of cool. So when I make a change to a microservice, you're telling me that doesn't impact any of the other containers? That's correct. None of the other containers on that application is going to go away. They're all going to be there, and it's all going to be fine. Wonderful. I like that. That's the way it should be, right? Yeah. But what about the actual service itself? So I have, say, for example, 3 pods or 3 containers. They're doing the same thing. They're replicas. What I'm going to do when I need to push an update is I'm going to create a brand new container and then delete one of the old ones. Create a brand new container, then delete one of the old ones. Create a new container, then delete one of the old ones until we have incrementally removed all the old containers and we have nothing but new ones. That is the reason why when you're playing Diablo IV, they push server-side updates that includes balance changes from like loot, etc., store updates and everything without it ever touching your client. You don't get downtime. They're pushing to production on Diablo IV several times a day. Several times a day. Say what you want about their game design. Say what you want about what Diablo IV does in terms of its gameplay and its class design and its gameplay loop. But their server-side tech, their CI/CD operations, the way that they run their DevOps, it's one of the best operations I've seen in games, period. Now, you can sit there and complain about various outages or issues along those lines, but look, games are some of the most complicated applications we launch. They are. They just simply are. But their whole CI/CD pipeline is pretty darn good. It's stellar. They're doing great work over there. So all that being said, they push to production several times a day without any outage. You wouldn't even notice it. They're always making changes. They're always retooling. They're always rebalancing. And they do it several times a day. That's pretty impressive stuff. So that's why Kubernetes. That's what we get from Kubernetes. Any questions so far? Let me go ahead and remove my face here so you guys can screenshot this. Remember Atlas, their infrastructure was cool for multiplayer. It was very much an old monolithic approach to it until it wasn't. I think they ended up changing Atlas because I swear it was a regular server-based approach, but then suddenly it wasn't. And I don't recall what they did when they changed it. But I do remember Atlas, and I remember they did make a change to how they were handling their servers. But they were microservicing, and you're correct. You're actually right. Now that I think about it, you're 100% right. So what Atlas did, and I'm glad you mentioned that, Man, what a good example. Yeah, let's talk about Atlas. So what they did is that they said, hey, we're going to have like a 24 by 24 grid. That's our game world. Okay? And every single one of that, every single section of that map is its own server. So every section is its own server. I think this is what you're talking about. And so since it's its own server, every section is basically its own container. Now, what you would do here, and we're going to talk about this not today, but certainly in the future, is you're going to create a stateful set. Because when I have a player go from one grid to another, I need to directly connect that player to that container. It can't be chosen by a load balancing algorithm. It's a very specific redirect to a new container, to a different container. Okay? So every section was its own server. Now, they were probably doing this. Atlas probably did this with VMs. They probably used a virtual machine for every server. I would have done this with containers, with a stateful set, to be more specific. But Atlas came out in, 2016, 2015, 2016, 2017, in that area, I think 2017. They probably did this with virtual machines. I would have done this with containers. And here's the reason why. Because this happened in Atlas. Okay? That happened in Atlas, where, let's say, for example, a grid is down. A VM goes down for whatever reason. Okay? It goes down. Now, that part of the grid is inaccessible. And this happened all the time when you would try to go into another part of the map. And remember that big seawall you would see? It would be red. And that would indicate to you that that virtual machine that was running that part of the world was down. So now that grid is inaccessible. This typically happened because what? This typically happens because there are too many players connected to the grid, or the grid is down. So your high traffic map areas were constantly difficult to connect to. It was always hard to connect to them. So those really popular areas of the map where the really big mega tribes were living and all that stuff, they couldn't get to it. But if I did this by way of a container, so let's say I do this by way of a container, I could scale and add more resources through load balancing. And I'm going to do this by load balancing the auxiliary or the back end portions of the operations, not the front end. Why? Well, that's because I can't necessarily replicate the world, but I can replicate the back end services. I can't replicate the world because I need to make sure that player A can see player B chopping down a tree in real time. If they're on different containers, that connection is not happening through subsequent network connections, and that will create an issue in terms of latency. But we can do the containerization, a way of a containerized back end, which would then relieve that one virtual machine of all the back end processing that it has to do. And instead, we're going to have a container that's going to be solely focused on the front-end operations that help deal with player location, what you're looking at, what you're seeing, what's happening, what's actually going on in the state of the world. World state is going to be maintained by that one stateful container. Now, can we have an issue? Yep, but self-healing will bring that container back, and with a stateful set, it'll come back with a consistent host name and its own storage class. So it would be able to reload the whole map data probably in a matter of seconds. So the outage would be very short, and you can mask the outage by not closing the clients because the VM went down, because all the other backend processes are there. So what ends up happening is you get an outage that just feels like a 4-second glitch where we just kind of lagged out for 4 seconds and we're fine. That's a way better result than what we were dealing with Atlas, because they were doing it by virtual machine. So they were trying to essentially microservice the game world, but with virtual machines, which are not microservices. Very different. So hopefully that kind of puts into context what Atlas was doing with their server tech versus Kubernetes. But that's how I would handle that. So, oh yeah, no problem. So now that we've had a chance to talk about why Kubernetes, we got Kubernetes up and running, I want to quickly remind everybody that if you want access, and again, just a quick shout out to the people who are helping us out with providing the infrastructure that we're using to play around with Kubernetes. That would be Alta 3 Research. We're using their labs, and I want to quickly shout them out again and share with you where you can get a hold of the same student environment that I'm using. You can jump on into this webpage. This is all about Crush the CCAD, or Crush the CCAD exam. This is a product that I built. I love this product. It's awesome. And if you go to that page, you can click on Self-Paced and click on Start Today, and that'll get you up into this page where you can then deploy Kubernetes using the procedure that is provided here for you, and then you can begin taking your mock exam tasks. If you don't know anything about Kubernetes, don't worry, there is a video. There's a video tutorial that features yours truly for every task. So if you know nothing, you can watch the video and then you can begin tackling the tasks. This is a great way to learn Kubernetes. It's very focused on how to Kubernetes, not so much the theory behind it. But don't worry, I'm teaching the theory behind it right now, and why we use Kubernetes and everything along those lines. So there you have it. Okay. Now, let's get back to what we're going to do next. So what we have now is we have Kubernetes. We understand what Kubernetes is. We've talked a lot what is a container, and we've talked about what is a cluster. Now, the next thing you need to do is understand what is a pod. What is a pod? And then once we're done talking about what a pod is, we can then break out how we would actually utilize Kubernetes to schedule pods, which contain your containerized workloads. Now, a pod is very easily defined as a group of one or more containers. Wonderful. We're going to put them on a pod. Okay, we're going to put them on a pod. No, we're not talking about pod racing from Star Wars. We're not talking about a pod of dolphins that are in the sea. And I actually use this example when I teach artificial intelligence. But no, I'm talking about a Kubernetes pod, which is a group of one or more containers. But it's so much more than that. And that's typically where everybody else's explanations end. Oh, a pod is just a group of one or more containers. Hey, I mean, no, there's so much more coming on. There's so much more happening. Remember those 7 namespaces of isolation that we talked about with a container, right? There's 7 of them. Well, guess what? Containers on a pod will share 3 namespaces of isolation. What does that mean? Oh, that means that they're going to be on the same namespace for that particular bit of isolation. What 3 namespaces are we sharing? These are the 3. They're going to share network. So now all containers on a pod have the same network, IP address, right, etc. Well, that's pretty dope. All right, what's next after that? Well, then after that, they're going to share IPC. So an average panda, if you're still here and watching. Inter-process communication. You asked the question, can I get containers talking to one another? I said yes, via network, but you could also get the containers talking to one another via IPC if those containers are on the same pod. So now all containers on the pod can talk via kernel space. Now, this is important to know and understand because let's say, for example, I have these 2 containers and they're talking to each other all the time. They're always talking to one another. And because that communication is happening over network, we're creating a bottleneck. Uh-oh. And now data starts piling up. Now, one solution might be we'll just build more containers. All right, yeah, sure. We can provide more physical resources to the problem, but it's not about CPU or memory, but rather it's about data throughput. By having these two containers on the same pod, and then on the software level, this has to be done via code. We get those two containers talking to one another via the software level. Now they're getting about 10 times the throughput than they used to get without any added resource requirement. Just now they're communicating over IPC versus over network, which is far more efficient, much faster. So if I have these two containers that work a lot together, why don't I just put them on the same pod? And that'll speed things up. That's real cool. And then the next thing that these pods are going to share is they're going to share UTS, which is a fancy word for host name and NIS domain name. Okay? So they're all going to be on the same network. So they all have the same IP address. They're going to be able to talk to one another via IPC through the kernel space, which is way faster. And they're all going to share the same host name. Now, typically the question is, but Tim, but B-dubs, forgot, I'm not teaching a class where they know my name. I mean, everybody knows my name, but I'm teaching. I'm just having fun on a. Anyways, here's the deal. But B-dubs, how can I send network traffic to one container and not the other? We do that by port. So if I need to direct network traffic to a specific container on a pod, you do this by specifying the port of the container. Remember that containers are exposed on a specific port. Traditionally a 4-digit number. You can make it whatever you want. And that is how you can direct network traffic to a specific container on a pod. So we'd use the pod host name, then the port, and that would direct us to the specific container that we're looking for. It's not about using more powerful hardware. So the question from Tylerian Gaming is, hey, is the idea of using IPC better because we're using more powerful hardware versus using network? I would tell you that the difference is the way in which the traffic is flowing. And the best way I could show that to you, and I'm not going to break out into a course material too often. I can only do it so often, but I'm gonna do it now. And let me break out our CKA course real fast. Boom, boom, boom. And what we're going to look at is very briefly. Here we go, this slide. So traditionally, when we do not have IPC, okay? I mean, we have no inter-process communication because these two containers are on their own isolated namespaces for, let me go ahead and get my Epic Pen up and running. These two containers are on their own IPC channel. So they can't communicate via the kernel space. They're not allowed to. It's impossible. They're isolated. So now our process goes through the kernel space to the network, then to another network, through the kernel space, then into the process. That's a very, very, very long road, right? Right. But if I were doing this through the kernel space, it would look like this. That's a very short road that only requires the kernel space. This is blazing fast. This is something that we use programmers to set up, is have one process talk to another process. And we can hook many processes together to create programs or full-scale applications, right? So what we're talking about, Tylerium, to make this just, to make this, why is it faster to go through IPC versus through network? The road is shorter. If you want to like just take it down to layman's terms, the road's shorter. I'm just hitting the kernel, then to the process. I'm not hitting the kernel, right? And then off to some virtual network, some VETH that's sitting right here, right? Then through another VETH, and then back to the kernel, and then to my process. That's a way longer road. Well, then your next question is, well, then, B-dubs, why don't we just put everything on the same pod? Well, then you're rebuilding your monolith, and you can only have one node. Oh, because all containers on a pod must be scheduled to the same node. You will never have a pod with one container on node 1 and then another container on node 2. So that gets rid of our ability for failover protection, self-healing, and all sorts of other stuff. So we choose when we would want to have two containers together to utilize IPC smartly and wisely. And we use it on specific use cases that can get rid of things like bottlenecks or really, really tight dependencies between two containers. So, yes, IPC enables a shortcut. Cool. Any other questions? That was a great question. Now, these are better questions than I get in my normal classes. This is awesome. And normally that's because my normal classes are typically corporate and everyone's afraid to kind of look silly because they don't want to look silly in front of their peers, so they don't ask questions. Awful decision, by the way. Ask all the questions you got, right? Because this stuff is difficult to visualize. Can be. So feel free to ask. Any other questions? I'm a beginner with this stuff, but does a kernel space use RAM or where in the memory is it used? So your machine is basically going to be using the RAM. But think about it this way. It's not that the kernel uses the RAM. This is an excellent picture. I'm going to use the same picture, right? This process requires CPU and memory resources to run. But it cannot just say, hey, give me CPU. It can't do that. No, cannot do that. Instead, the process needs an interface to the CPU and the memory. So the interface is the kernel. So the kernel is what will provide the interface to your CPU and to your memory. It's also what provides the interface to things like your file system or things like mount points. Everything happens through the kernel space. So if we're talking about kernel, and what is the kernel? Well, the kernel is everything. It's the clearinghouse for all I/O. So as your processes require resources, as they need access to a file system, if they need access to mounted file systems or memory or network, it's the kernel space that handles all of that I/O. You cannot have a process directly talk to a CPU. Can't do that. You can't have a process directly talk to another process. Can't do that. It has to go through the kernel space. You can't have a process directly talk with a network interface. Can't do it. It has to go through the kernel space. So that's what the kernel space is used for. It is the interface that handles all I/O, any input-output from the process, whether it needs CPU, memory, so on and so forth. That's what it does. I think that answers your question, Tylerium. Awesome. So with that being said, now that we've had a chance to kind of discuss how these namespaces of isolation are actually being shared by a container. When we talk about a pod, because we're defining what is a pod, it's simply a group of one or more containers that are sharing these three namespaces of isolation. Wonderful. That's what's up. I like that. That makes my day. It just makes my heart sing, and it's wonderful. Because now, as a system designer, I have options. See, back in the day, when I just had containers, I didn't have an easy solution for how could I make I/O between container 1 and container 2 faster. It had to happen over network, so my only option was to replicate the containers. And in some cases, that was really bad and difficult to do. Now I could just put those two containers on the same pod and voila, they're talking to each other real fast, and I can still scale it, but I'm not consuming more resources as a result. I just shortened the road. Way more efficient. Way more efficient. So now that I'm able to design more efficient services with pods, pods are a powerful, powerful thing. The next question is okay, I have a pod. It's a group of one or more containers, and all the containers are going to share those three namespaces of isolation. How does my pod get onto a node? Well, now that's where Kubernetes comes in. Kubernetes has a control plane component, and we'll talk about the control plane here, called the scheduler. Now, the scheduler, its job is to schedule workloads onto nodes. The scheduler does this intelligently and equitably. I use both terms. Most people don't. Let me tell you why. The scheduler's job is to utilize every node in your cluster equitably. Equitably means that I'm just going to look at available resources as a percentage. And so if I were to deploy all the workloads that you've scheduled to me, and if I were to equitably distribute them across all of the nodes, I would only maybe consume a percentage of all the nodes, right? Well, I'm going to keep that percentage the same across all of the nodes. So if I'm only using 20% of node one's resources, I would want to try to use 20% of all the other nodes' resources. And as more demands are coming out, I'm going to try to schedule workloads to equitably use all of the nodes. The reason why we do this is because if I have a node failure, it's not going to create a major catastrophe on my cluster because I have been equitably distributing my workloads. Instead, we just simply redirect users to replica copies of those pods that are available on other nodes, which is wonderful. That's the way it should be, right? But the other thing, too, is that I don't want to have things like out of memory or CPU issues on a node and while other nodes aren't being used at all. I want to use all of the available hardware. So this prevents us from stressing any one node in particular. Right? The scheduler is going to make sure that we're scheduling pods where they need to go and that we're scheduling pods on nodes that have what we need. Which then brings me to the next main point, and this is usually where developers get mad at me. But I tell them, no, stop it, you're wrong, and I tell them why. Okay? So, application developers, you guys who write code, okay, have no notion on what node is running their pod. I do not want my application developers to know what node is running my pod. What virtual machine, what physical machine is running my pod. I don't want you to know or care about it. But B-dubs, yeah? What if my pod requires certain hardware? Okay. Then you care about what set of nodes is running your pod, but not what individual node is running your pod. So let me explain. I need all of my pods to be able to run on as many nodes as possible. Because if I have node failure and that node happens to be the only node that's capable of running my pod, what happens when that node goes down? Well, I lose my pod. We have an outage now. We have a degraded service. Failover can't happen because my pod must be on node 1. Well, that's bad. That defeats the purpose of using Kubernetes. But you might say, well, B-dubs, I'm running machine learning. Ooh, and I need my pods to have an A100 or a B100, 200, or an H100, whatever it is you're using, right? Well, that's an actual physical graphics card. It's in a physical machine. And I need to make sure that my pod lands on a node that has one of those cards. Well, then have 3. So when we have a need for specific hardware or maybe an operating system, Okay? You're going to want to schedule on a set of nodes. So have at least 3. I don't care which one of those nodes my pod lands on. Just so long as I land on a node with an A100 card, I'm good. What's going on, Kenneth? Good to see you. We're in the middle of teaching Kubernetes a little bit. We're now on to defining a pod. And I wanted to appreciate you. I'm going to send a quick thank you, Ken, for the support on that GoFundMe. I appreciate it. And hopefully we'll be in touch with my kiddo soon. But I'm pretty sure she would appreciate it as well. That being said, pretty sure. I'm 100% confident, actually. She appreciates it a lot. She's going to cry when she finds out how many people actually stepped up to help her. She's going to be very touched. That being said, getting back to the topic that's at hand. So when we are scheduling pods, we don't care about what node that land on. When we do care, typically it's because we're systems administrators. We do care. We'll talk about why later. We do care. But we typically don't care which node our pod lands on. We shouldn't care. As soon as you start caring about where the pod lands, you're probably using Kubernetes wrong, and you need to reevaluate your approach. I have a lot of people coming to me saying, I must have this pod on this node, and typically it's because they have a failure to understand either an alternative method of achieving the results that they're looking for, or they don't know what they're doing. It's just one or the other. So in any particular case, just bear that in mind. All right. So now we know what pods are. Let's get into the next thing. And this is the last thing I'm going to go over today. And if you're interested in what we've been doing with Kubernetes and learning Kubernetes, we'll do this again tomorrow around the same time. I'm going to be shooting for around the same time. Okay. I have a meeting with the attorney tomorrow, so it might be a little later than today. So with that being said, we're going to schedule on a set of nodes. We're going to have at least 3. All right. So now we understand what a pod is, which is a group of one or more containers. Containers on a pod will share 3 namespaces of isolation: network, IPC, UTS. We're going to have directed network traffic to a specific container on a pod. We're going to do that via a port. And then we're going to be intelligently and equitably distributing workloads using a scheduler. And then application developers, they tend not to know where the pod lands, and that's good. That should be going live time. I should not be talking to myself again. That was awful. All right, everybody. So we must have at least 3. Let's get into actually deploying a pod. And there's so much more I want to teach about this, but I'm not gonna. We'll save it for later. But right now, let's run some kube control commands. We'll do a kube control get nodes. These are the 2 nodes that we have. We have node 1, we have node 2. Now, there is a controller node, but we're obscuring the controller node from your view because the way we look at it, when we play the way we'd like to do in production. If you need to know what the status of the controller is, you should be a systems administrator who knows how to do it without using kube control. So we've obscured it. You can't see it. You're going to have to go figure out how to do it yourself as the sysadmin person that you are. So we only see the 2 worker nodes. There is a controller node. Now, you might be asking, okay, we know about pool of nodes are B-dubs, but you mentioned control plane. You're mentioning worker node. What are you talking about? We have a controller node. Okay, this is where the Kubernetes orchestration components live. We tend to have 3 of them. And that's for quorum for etcd, and that's also for failover redundancy. Okay. And that's where your Kubernetes orchestration components live. That's where the scheduler lives. That's where the API server lives. That's where etcd lives. And we'll talk about those other control plane components sometime later. But that's your controller node. Then you have something called a worker node. And a worker node, yeah, is where our application pods live. Okay? That's what's actually going to be hosting our actual application. So we tend to separate them out. So node 1, node 2, those are both worker nodes. Wonderful. So with that being said, when I create an application pod, my application pod's going to land on node 1 or node 2. It's not going to land on the controller node. So let's get into it. So now that we've done all of that, let's take a look. Let's use Batcat. I like Batcat. And we're going to take a look at a manifest that we already have, and it's called Simple Pod. Wonderful. And this is a pod manifest. How many people here, I'm curious, I'm asking the chat, how many of y'all know what it is we're looking at? What kind of file are we looking at? Now, admittedly, the answer is in the file extension. One with words, and I love it, Cheyenne. Thank you. Average Panda, Tyler, my two techie folk who are here. Anyone know what we're looking at here? Look, guys, you ready? There you go. Kenneth figured it out. Way to make yourself look smart here. It's a YAML file. Just remove the dot, and you would have gotten there. Just that. All right. That's it. Yes, it's a YAML file. Now, YAML stands for, and this is true, YAML ain't markup language. It used to stand for yet another markup language, but then someone rightfully pointed out that YAML is not a markup language at all. Okay? So YAML ain't markup language. Well, that's nice. Well, then what is it? Well, what it is, if it ain't markup language, YAML is a superset of JSON. Does anybody know what JSON is? So far, it looks like the answer is no. Tiny clue, busy at the moment. Okay. All right. JSON is just JavaScript object notation, right? It's a way for us to define an object, data, arrays. So, say, for example, if you want to know Python, right? In Python, JSON is very much like a Python dictionary, okay? In which we have key value pairs. Key value pairs. That's what those are. Key value pairs. JSON is a data structure that's based entirely on key value pairs. When I say key value pairs, think about just defining a word. Right? So bicycle. A vehicle propelled by human exertion on a gear connected to two wheels. Cool. Well, that's wonderful. That's what a bicycle is. A vinicle. Okay, point is, that's key value pair, right? You had a key and you have a value. Wonderful. I love this. That's a bicycle. All right, that's key value pair. That's what we're talking about. So let's go and let's get the back cut up and running again. There it is. And since we understand that now, okay, these are key value pairs, you could clearly say, hey, here's a key, here's a value, here's a key, there's a value, here's a key. That seems to contain a key with a value. Yep, that's what it is. It's a dictionary of dictionaries. I heard you like dictionaries, so I put dictionaries in your dictionary so you could dictionary while you dictionary, right? That's what it is. It's just a dictionary of dictionaries because you can have multiple values within this collection. We would call that a collection. Here's another collection which contains a key called containers, which then contains this dash here. That dash is an array. It's like a list object. And so this is how we end up defining our pods. Cool. So now let's break everybody's brains and let me show off here real quick. I'm going to do something. I'm going to do the fun little exercise I always like to do. And I'm going to write a pod from memory. Pod from memory.yaml. All right, here's what we're going to go ahead and jump on into. And I got a question. Hey, wouldn't we be playing video games here soon? Yeah, it's called Kubernetes, coffee, and games. We'll get to games. But right now we're writing a pod from memory, which is like a game for me. So when we're defining an object in Kubernetes, it's more than just defining a pod. It's like other objects like services, deployments, replica sets, network policies, ingress control, the whole nine, right? There's so many different resources that you could play around with in Kubernetes. So let's say, for example, I'm doing API version, right? And then I'm doing kind. Then I'm going to have metadata. And I'm going to have spec. And then there's a fifth key that we don't care about, but I'm going to write it anyways. It's called status. Most Kubernetes objects are defined by these four, I'm going to say specifically these four parent keys. So when you're building a Kubernetes object, those are your parent keys. Now, why do I call them parent keys? Because those are the keys that are up against the left-hand side of the margin. Nothing owns those keys. Nothing owns them. They're their own parents. So API version, what is this? This is where we specify the API group and the API version of a resource. This is not like Docker Compose, where I might have a version that is the version of that particular compose file that's just arbitrary and whatever I want it to be. No. This API version is looking for something specific, and we'll talk about that. Kind. This is the kind of resource we are wanting to build. Metadata typically contains high-level information concerning the object being built. Spec are these specifications describing the object. Status, simply the status. We do not write this. Okay? The status key is something that is maintained entirely by the API server. We won't touch it. We won't edit it. We don't make it. We don't care about it. But it gets added later on, and you'll see that. So we'll delete this. That goes away. Wonderful. So now that it's gone away, I'm now left with 4 parent keys. We don't care about it. Let's start defining these parent keys. Now, YouTube University is a thing. And even though I recognize I'm currently on YouTube, what I usually like to say is that YouTube University is a terrible place to learn because you run into a lot of bad information out there. And here's one of them. I saw someone say this on YouTube. Okay, we're going to put in V1 here for a pod. Well, wait a minute. B-dubs, didn't you say that we need to specify the API group and the API version? We do. So, for example, if I were writing a deployment, for example, a deployment belongs to the apps API group, and therefore I'm going to write in apps/v1. Well, then why is it that when I have a pod, which belongs to a different API group, we leave that blank? And here's the reason why. A pod belongs to the Kubernetes core API group. And the way that we identify the Kubernetes core API group is with a null value. So whenever I am prompted to provide an API group, and I want to identify the Kubernetes core API group, I provide a null value. By providing a null value, I'm saying core. So we write nothing for the API group, and that means I'm actually specifying very specifically the Kubernetes core API group. I have heard people teach this as saying that, oh, pods don't have an API group. Not true. They do. It's called the core API group. Or they say, yeah, if you write in nothing, that's just basically saying use the default API group, which that's not what it's called. Or they'll say, oh, that's just a catch-all. You could do that for any resource, which is clearly not true. So that's what's up with API versions. Really cool stuff. So we'll delete all this fun stuff. Just get rid of it. Bye-bye. There we go. We're good now. Awesome. And we have our API version. So then we're going to have a kind. This is the kind of resource we're wanting to build. Wonderful. And now we're going to get into metadata. Pod's all you need. We're building a pod here. Really easy key to understand. Now, metadata is typically right in the name of the object. Now, names must be unique within a given namespace for namespaced objects. For a cluster scoped object, they have to be unique across the whole cluster for that particular resource type. And for this one, we're just going to call it pod from memory. And then we're going to put in namespace. We'll talk about namespaces later, but namespace, we'll just say default namespace. That is an actual namespace. It's called default. And then we're going to put in labels. And labels are just tags that we can put onto an object to help me search for them. This is like old school search engine stuff, right? We used to have to tag our websites. So if I typed in something like hamster dance, right? Any website that had the tags hamster dance would be pinged, and we would rank those based on how many clicks they would get from the search engine. So the actual hamsterdance.com, for example, would be at the top of the list because everybody wants to see those hamsters dancing, right? Same thing. Like old school tags. But in this case, we're going to say App Engine X, right? And we're going to say, I don't know, roll front end. And I usually like to have a point of contact. We'll say B-dubs. Let's do that. We'll say B-dubs. Wonderful. Awesome. That's me. So let me get spec. Now, spec is like specifications for describing a particular object, but I'm going to get rid of this description here because we're going to talk about this later for a pod specifically. But typically under spec, you have containers for a pod. Now, when we're defining a pod, there are two levels of specifications. One is a container level specification, and the other is a pod level specification. Settings made at the spec level will impact the entire pod and all of its children containers, whereas settings made on the container level are only going to impact the individual container that we're working with. Now, I have a feeling that you all are new to YAML. Glad you all are new to YAML. Here we go. Here's what we're going to do. We're going to create an array. What? Yeah, that's an array. It's a dash. Now, you'll notice the way I formatted my YAML file so far has been just through key value pairs. Here I have a key that contains multiple values, name, namespace, and labels. And these values are they themselves, well, dictionaries. They're key value pair. Labels is a collection. It has multiple values as well. So we have dictionaries within dictionaries within dictionaries. Isn't that wonderful? That's wonderful. I love it. Then we get into spec. Now, under spec, we have containers, which is a container level specification, right? But then all of a sudden, containers has this dash. This dash is a list object. So let's just say, for example, I wanted that list object to be a string. I could just cheese. There it is. That list object is just now a string that says cheese. That's it. Okay? And then I might have something over here that says mayo. Might have something over here that says bun, right? Might have something over here that says burger. Okay? And these look like ingredients or parts of a hamburger. Okay? Lettuce, tomato, right? These are just neat little strings. That's all they are, right? That's perfectly fine. Now, will this do anything for me? No, not in Kubernetes land. But as far as YAML syntax is concerned, that's perfectly acceptable. That is an array of strings. These are list objects. List objects are zero-based. So if you're familiar with Python, you would have a list. You would recognize that that list is zero-based. And if I wanted to slice a particular object off of a list, I would do so using square brackets and then the number. And 0 is typically the first entry, right? So this here, for example, would be indexed as 0. Mayo would be indexed as 1, and so on and so forth. Okay? So this is a zero-based index. So now that we have that cleared up, let's talk about what we're actually going to be doing, because I can have multiple containers in a pod, right? But it's an unpredicted number of containers. Most of my pods might just have one container. But since there's an undetermined amount of containers that could be on a pod, we have to use an array. So this dash is basically saying, hey, I'm going to define a specific container. So let's define a container named Nginx, which is a neat little proxy web service application. And I'm going to say I want to grab the container image Nginx 1.23.4, because why not? Then we're going to have another container here called BusyBox, and that's going to be running an image called BusyBox 1.34.0. There we go. Perfect. Now I have two containers. One container is called Nginx. Another container is called BusyBox. Now, if this helps you understand how this data structure is being formatted, check this out. I'm going to go ahead and bump these out, just like that. And now I'm going to create a new line. And there we go. This is valid syntax. This syntax is perfectly valid. Containers owns an array. That's a list object. That's a list object. This list object owns these two key value pairs, whereas this list object owns these two key value pairs. Everything that is owned by this dash is defining this a single container. That container that dash owns. So this container is going to have the name Nginx. It's going to have the image Nginx 1.23.4. Meanwhile, this dash is specifying objects for a second container. So another container is going to be on there. That's going to be named BusyBox. So it's going to be running that image, BusyBox 1.34.0. So it's way easier for us to visualize this when we structure it like this. But this is purely a style thing. This will work. This is valid syntax. There's nothing wrong with doing this. But most people won't write their manifest this way because that takes up way too much space. So what we end up doing is we'll go ahead and we'll have our dash actually sit underneath the key that owns it. And which is perfectly acceptable. Typically, we don't do it this way, right? Typically, we don't do it this way. A lot of folk will actually do it this way. They'll keep the space there just to keep the casing and spacing uniform. But I personally like to style it this way, where the dash is underneath its own key. That will work perfectly fine, and I do that to keep things condensed. Okay? So now the next thing, since many of you are new to YAML, is that you have to understand that when we are calling for a particular value from a key value pair, we do this all the time in programming. If you're doing something like APIs and you want to grab a particular key value pair off of a JSON payload, you're going to need to do something called write a JSON path expression. So a JSON path expression is essentially an expression used to map to a particular key value pair. Or object in a JSON payload. Remember that YAML is a superset of JSON. And as a superset of JSON, we can easily convert YAML to JSON and JSON to YAML. The difference between the two is that YAML is just easier for humans to read. That is, of course, unless you are like my brother, who is more machine than man. He prefers reading JSON. What a weirdo. Anyways, point is, most people would agree that YAML is way easier to read. So we need a JSON path expression in order for me to say, hey, this is the key value pair that I'm looking for. Now, we teach this in our classes because a lot of documentation that you will run into will not write out nice, fancy manifests like this for you to copy and paste. Instead, they will show you JSON path expressions. They expect you to input that JSON path expression into your manifest file. That's what they expect you to do. So we need to learn about JSON path expressions very quick, and that'll help you with understanding documentation. So let's delete all that. So let's say, for example, I want to get the value for this key role. I have to write a JSON path expression to the role key in order to extract the value, and in this case, that value would be front end. How do I write that JSON path expression? Well, it's simple. We begin with the parent key, so it'd be metadata dot, so metadata dot, the next key, labels, dot, role. If I write that in as a JSON path expression, I would get back the answer front end. Now, this is where things get fun and fancy. Well, what's the JSON path expression for this key? Well, with arrays, they get a bit more complicated. But we begin with the parent key, spec, then containers. But containers is an array. And if you know Python, right, you will recognize this. If I'm slicing a list object, when I get to the list itself, I am then going to open up a square bracket and then say what index I care about. In this case, I care about index 0 because that's the first object. This right here is index 0. That's the first object in my list. And I want to get the image. So it's spec container 0.image. And I'm going to get back the answer in Nginx 1.23.4. Okay. So that's a brief breakdown of JSON path expressions. You need to know how to do that, especially if you're working with APIs and you're gathering JSON payloads. But if you are trying to write documentation, say you have created your own custom resource definitions, or you're trying to instruct somebody as to how to configure their pod, you're going to want to provide that information by way of the JSON path expression and not a whole manifest, right? If you only need to know one key value pair, I'm just going to send you that one key value pair by way of a JSON path expression. And this is what those look like. Expect to see that in documentation. You would even see this in Kubernetes.io documentation, which we'll probably show later on at the end of this demo. Cool. So now we have that understood. So now I'm going to delete these. I don't need those anymore. And there's a few other things I want to show off here without getting into too much detail. So let's say, for example, I want to launch this BusyBox. BusyBox is a special kind of container image because it does not have a command or an entry point in its Docker file. So if I do not give it a command, it's going to do nothing. BusyBox is just a neat little box that'll do whatever command you give it. So I need to provide it commands. I'm going to do it this way. I'm going to say args. The reason why I'm going to do args is because I want to show you that at any point, if you want to start writing JSON, you can. And I will, because I want to start writing JSON. I'll show you why. So I want it to run an sh shell, and I want it to run any command. And the command I want it to run is sleep for 3 hours. I just want this container to spin up, do nothing for 3 hours, and then shut down and die. That's all I want it to do. I'm going to write inline JSON. I could do that. Remember, the YAML is just a superset of JSON. So when I go to convert this to JSON, this JSON data that I just wrote here is going to convert one for one. No change will occur to it. I could just write JSON inline at any time and it'll work. This will work perfectly fine. But what if I wanted to write this in the YAML way? Well, let's go ahead and let's comment that out. And let's write this in the YAML way. The YAML way would be this. These are the same objects. They're both arrays. They're both sequences. They're both list objects, depending on which term you prefer to hear. Okay. They're the same thing. We're just writing them out differently. But I prefer what I've done up here because it's a very simple command. I'm not having it do anything crazy complicated. And I'm trying to save space in my manifest file, so I'll go ahead and I will make a style choice of writing it like this. It keeps things nice and condensed, and it feels good. Now, let's continue on. So now that we have a good understanding of what all of this is about, let's talk about what else I could put in a pod. Well, typically, I'm going to want to write something to disk. Or maybe I'm going to want to have some type of security. Let's do security. Let's do that first. So I'm going to write something called a security context. And a security context enables us to define things like what users and groups our service account should become and its permissions, as well as different things like AppArmor or SE Linux profiles, things of that nature. So I could say, for example, run as user 1001, run as group 3001. Perfect, right? But let's say I come down here. Security context is cool because I can write it on the pod level, and I can also write that same, my gosh, security context on the container level. Well, let's say I'm going to do run as user 1101, and let's do run as group, let's say 3101. Or 31,001, 11,001. There we go. Or 3,100, 1,100, and yeah, I was right. Anyways, whatever. Point is, which one of these would take priority? Do you think the pod level specification would take priority, or do you think the container level specification would take priority? Now we get to find out how many people are paying attention. Because, look, you don't need to know anything about Kubernetes to answer this question. Do you think the pod level specification takes priority, or does the container level specification take priority? You got a 50-50 shot. Tylerium says pod. Does anybody have a different answer? If given the choice between pod and container, and Tylerium said pod, I said I need a different answer. There's only one other answer left, and that other answer is container. The container level is what's going to take priority. Now, why is that? Well, think about it this way. Imagine, if you will, that I have a pod that's going to have 3 containers. 2 containers are something that I have written. Those are our code. It's our in-house code. And we have a regular user that we use for the service account to run those containers. So let's say it's user 1001. Okay? Oh, it's okay, Tylerium. You didn't miss what you needed to answer that question. It was a pure guess. It's fine. All right, so for two of the containers, it's going to have the same security context, but then I have a third container, and the third container is some COT software that I downloaded and I want to use on my particular on my pod. So that one's going to have a totally different security context because a different dev team made it, and they have a different expectation for what user ID should be accessing, the privileges on that particular container, et cetera, et cetera. So they might have a totally different security context for that particular container. So that enables me to set my security context for my applications on the pod level, but then individual security context for stuff that's not my software, for my COTS. Right, for my commercial off-the-shelf stuff. Okay? That's the reason why container level will take priority. Now, we can do some other fun things with the security context. Say, for example, I want to allow privilege escalation. We'll set that to false. And then let's do read only root file system, and we'll set that to true. So what this is going to do is this is going to prevent me from becoming the root user or escalating my permissions to a user account that is higher privilege than my own. So I can't switch users to root, I can't switch users to any higher privileged user on that container. Then a read-only root file system means that I cannot write over my root file system. I would be unable to do so. Why would I set that? Well, for a security point of view, bad guy attacker man is going to try to do what? Install their malware into your system. If you get into a particular container where it's possible for them to install their malware, that would be really, really bad. So we want to prevent writes to the root file system, and that will protect us from bad guy attacker man. Now, you might then say, well, but B-dubs, if I'm already not the root user, then I can't write to the root file system anyway. So isn't this redundant? And the answer is, yeah, you bet it's redundant. You're right. But redundancy in security is always the best practice, and here is the reason why. Bowser. Y'all know Bowser. We've all played Mario. Bowser is the king of security. It's what he does. Bowser is a security expert. Now, you might think to yourself, well, how come Bowser's always getting trounced by Mario? That's because Mario has infinite lives and can tell the future because he's died on the level many, many times before. Mario is a Time Lord. Okay? And it's difficult to beat a Time Lord, but Mario also proves the point that given enough time and resources, any security can be defeated. This is a philosophy that people use in security circles. Any security measure can be defeated given enough time and resources. Therefore, being redundant protects us. So Bowser didn't just set up one lava pit. He didn't have just one Koopa Troopa or one Bullet Bill, but he had many. And he didn't just have one castle, he had 9. Across 9 different worlds. And Bowser was a very, very good security professional because he decentralized those castles. Whenever you would break into a castle, they would always tell you, I'm sorry, Mario, but your princess is in another castle. He was a security expert. He did a really good job. Okay? So Bowser, as the security expert whom we will look to for all ideas in security, he's a fantastic security professional, is not going to allow you to reprogram his bullet bills. Okay, that's the reason why you never see Mario take over a bullet bill or an airship. He never does that. Because Bowser is a very, very good security professional. You're not allowed to do that. Mario can't install his malware, and we're redundant. We have 2 levels of protection. 1, we're going to make sure you can't become root. And 2, even if you were root, you wouldn't be able to write over the root file system anyways. And then you know what else we'd add? Is an app armor profile that would prohibit root access as well. That's your 3rd level of redundancy. So that's perfectly fine. That's really good security practice. We like doing this. Very cool. So now that we've done this, what if I need Nginx to write somewhere? But I still want to have that security precaution of not being able to write to my root file system. Well, then I would need to do something. I'd have to add in a volume. Now, volumes are going to be defined on the pod level, so they're going to be under spec. I'm just going to call this security context volume. And this is going to be called an empty dir. This is an empty dir volume, and we're not going to specify any settings for it. So we're going to leave the value there blank. But empty dir is a very fancy term for ephemeral data store. Now, an ephemeral data store is a data store that's directly attached to the pod. And that data store will go away when the pod dies. That's why it's called ephemeral. It's temporary. It goes away when the pod dies. So now that we understand this goes away when the pod dies, now that we understand that'll go away when the pod dies. Forgive me, I was responding to a message that my wife sent me. Now, this is just a temporary volume. If I want this volume to survive, to last between pod life cycles, so the pod dies, comes back, I want that storage to still be there. You would use a storage class with a persistent volume and a persistent volume claim. Okay? But in this particular case, I don't care. It's a stateless service. We just need to write some files here while the pod is alive, and if it dies for whatever reason, it's no big deal. Okay? Then we can get rid of it. It's whatever. So that's what we're doing. We're adding a temporary data store that'll live with the life of the pod, but when the pod dies, so too does the volume. Now that I've added that volume, I need to mount that volume to the container. Remember that containers enjoy a mount namespace of isolation. So if I say volume mount, now I can say I want to grab the volume, security context volume, has to match the same name. That's us calling the volume that's on the pod level. And then I need to mount it to a particular part of the file system. So we'll just call it mount path, and we'll say temp. Wonderful. So now I've added an ephemeral data store to the volume, to the pod, and then I've mounted that ephemeral data store to the Nginx containers file system. So now we can write to the temp directory. So if that's the directory that Nginx is expecting to write its data, then we have configured this correctly. Now this is the fun part. This is where I like to have a little bit of fun. Okay, so we've done all this. We're having our fun. Everything's super cool. Let's go ahead and zoom out here real fast. There is our pod. Okay, there's our pod. Y'all think this is going to work? I did this all from memory, no example. I just wrote this. Are there any problems here? That was a lot of info. Welcome to a fraction of a day of training with me. And I skipped a lot. This is just a fraction of my power. Y'all think this will work? I think it'll work. I think it'll work just fine, right? Well, let's right quit on out of them. Let's get out of there. And I'm going to do a cube control. Apply TACF pod from memory. This is going to build this object in my Kubernetes cluster. And it says pod from memory created. Now, this is something that I skipped, but I'm going to teach it briefly right now. Does this mean that my pod is up and running, everybody? Yes or no? You got a 50-50 shot at being right, Tylerium. Does that mean my pod is up and running? Yes or no? Captain Admin says no. An average panda says no. Captain Admin and an average panda are correct. That does not mean that my pod is up and running. What does that mean? Well, we didn't talk about this, but there's a control plane component known as the API server. And the API server is what receives all requests. So, Tylarium, whenever you come to a conclusion, just think the opposite, and then you'd be right. So, an API server will receive all requests. Okay? All requests. When the API server goes through its admission control flow, or the admission controller, it's going to be doing a few things for us. Admission, not admission. It's admission. No in there. So we're going to do a few things for us. First thing it's going to do is it's going to determine who you are. That's called authentication. And then it's going to determine if you're allowed to make the request that you're making. That's authentication and authorization. The next thing it does is it mutates your requests, inputting any default settings that you did not include in your manifest. That's called a mutating admission. Then it performs object schema validation. So it's going to check to make sure that your syntax is good. So it's a syntax check. Then it's going to do something called a validating admission. This is a policy check. It's going to make sure that the pod obeys cluster policy. Once it does all those checks and changes, the next thing it's going to do is it's going to persist, or basically store your settings, manifest in etcd. Awesome. etcd is the Kubernetes underlying data store that stores all of your resource configurations, your state configurations for your cluster. So when it said pod from memory created, what it was telling you is that I have created this manifest in etcd. It lives in etcd now. Wonderful. We've done it. It works. Yay. But does it actually work? Well, let's find out. So only thing this tells me is that I was authenticated and authorized to do this. It added any default settings I did not specify. I had good syntax, and that I obeyed cluster policy. It's not checking to see whether or not the container is correctly configured, because Kubernetes doesn't care about your containers. It is not a container manager. It could care less about your container. So if I have bad container level settings, or there's some other issue, we're going to see a problem. So then how would I determine whether or not the pod is running? Well, I would need to use a kubectl command. Kubectl is my interface to the API server. Anytime I write kubectl, I'm saying, hey, send a request to the Kubernetes cluster API server. All right. So now I'm talking to the API server. I'm going to say, give me information about pods. Give me all the pods in my default namespace. And let's see what we get back. Uh-oh. We got back a problem. So even though it said that my pod from memory was created, what we ended up finding is that we're having problems. So we see we have ready. One container out of 2 is ready. And we have a status of crash loop back off. Uh-oh. And now this is restarted 5 times. Crash loop back off. What that means is that I have a container that is crashing. And so what Kubernetes is going to do is I got this container that's crashing, so I'm going to terminate the container, restart it, try again. Terminate the container, restart it, try again. It's on a loop where it's trying to get that container to spin up. And it's going to keep trying to get that container to spin up. And so far, it's tried 5 times to get that container to spin up to no avail. It's failing. Uh-oh. Uh-oh. All right, well, let's go figure out what's going on. Tylerium asked the question, I thought Kubernetes could automatically correct things. Yes, if things are correct. So what we're talking about with self-healing is that I have a container that's running and everything's fine, but then suddenly it goes down. We could set up a liveness probe that would determine whether or not the object is alive, and if we find out that it's not, we could then restart the container. That requires me to configure a liveness probe, which I have not done. In this particular case, the container can't even start, so it's never going to get healthy. So that means that it's never going to be good. In order for you to heal, you first have to be in good condition, I guess is the way to think about it. Okay? So we have a poorly configured container is what we're learning. One of our containers is dying. Why is that? Let's go find out. So we know one of our containers is dying, so we'll do a kube control describe. Now describe says, hey, give me detailed information about an object. So describe this object for me, and we're going to describe pod from memory. And I want you to pay attention to the bottom of the output here. We have events. And this is typically what I would say to do as a first step in troubleshooting. We see that we're missing a container, but I don't know which container is busted. So I'll describe the pod, and this will give me back information. Can anyone taking a look at the events tell me which container is busted? Which container is busted? That's the question. Anybody see? The bottom one. That would be BusyBox. Does anybody have a different answer? We have two containers. You have an Nginx container and a BusyBox container. Looking at the events, which container is our problem? The first container. Nginx is the problem. Here in this very last event, you'll see where we have the reason that we're sending a message. It says back off. And it says back off restarting failed container Nginx. Nginx is the problem child here. Right off the bat, we see here's the event. Nginx is the problem child. But do we know what's wrong with Nginx? That is the first container that I described, Tylerium, yes. Nginx is busted. Uh-oh. But we don't know why. So the best way to find out why is I need to read the logs. So this command is going to show me the log files stored on the container. And I need to specify which container I'm talking about. In this case, I'm saying I want to look at the Nginx container. So here is the log for Nginx. Why is Nginx failing, everyone? Why is Nginx failing? It's read-only. That's one of the problems, yep. It doesn't like the read-only root file system. It wants to write to root. That's one reason why it's failing, yeah. There's another one, though. From what I see, either needs super user privilege or is in read-only. Both. You're correct. Both. So here it says the user directive makes sense only if the master process runs with super user privileges. What it means is that my service account needs to be operating as root. Uh-oh. I didn't let it run as root. And then it wants to make changes to var cache nginx client temp, which is part of my root file system, which I've set it to read only. So I'm not letting it make that change. Uh-oh. So the container crashes and busts. So what the answer is, as to what's wrong with this, is that nginx doesn't like any security context. It hates security context. Any security context I give it is pretty much going to barf on me. So what I'm going to go ahead and do is I want to get rid of the security context for nginx. We'll just get rid of all of that. Question, did I fix my problem? Yes or no? Did I fix my problem by removing the security context from the container level of the nginx container? Did I fix the problem? So there it was. I'm going to get rid of all of that. That's the security context. I'll delete that. Does that fix my problem? No. Why doesn't it fix my problem, Tylerium? You're correct. You got one. Well, you still need security. No, this is still a busted container. Well, I agree we still need a security context of some kind. Right now, for this particular container image, I can't do it. But it's still busted. Why is it still busted? I deleted the whole security context from the container level of that container. Going on, Jason Stover. Good to see you, man. All right. Here's the reason why it's still busted. Guys, don't I have a security context specified on the pod level? I sure do. That means that we're going to set the user for nginx to be 1001, which means that it's not the super user. It's not the root user, which means that it will not work. So let's say I want to keep the security context right here, and I want to dump that into my busy box down here. So we'll do just that. So now I have that security context defined on the container level for BusyBox. And now let's get rid of the security context from up here. There it goes. It's gone. Now it's fixed. What's going on, Snipe? Now it's fixed. Now, what I'm going to have to do is I'm going to have to delete my pod before trying to recreate it or make a change to it. We could talk about the details as to why I have to do it this way later. What I'm going to do is I'm going to delete my pod from memory. I'm going to set grace period seconds to 0 because BusyBox doesn't respond to a sigkilt 15. I don't want to wait 15 seconds for it to go away. So now that it's gone, if I do a cube control get pods, you'll see we have nothing there. Let's do a cube control apply tag F pod from memory. And now it's created cube control get pods to see if it worked. And it did. And we're good. And it's wonderful. So that concludes our fun with containers. All right. Wonderful. Any questions about anything we learned today? We learned a lot. That was fun. 1 out of 3 right from me. Hey, that's better than 0. Any questions about any of that? You guys usually had good questions from me earlier today. I'm expecting 1 or 2 good questions now. Any questions? I'm not seeing any questions. Oh, good. Snow's expected to end soon, so I can go out and shovel it. Can't wait. All right, everybody. Let's get into something super cool. Brain hurts, no questions forming. No problem, no problem. We'll be back tomorrow with some more learning, but I want to get back onto something very important here. And I'm going to split this into two parts because I need to get out and shovel snow so that way people can get in and out of my driveway. So I'm going to be ending the stream here presently, but when we come back, we'll jump into a game. So I want you all to think about what game you all want me to play, okay? I'm tempted to either do Diablo IV or Baldur's Gate 3. I've never finished a full playthrough of Baldur's Gate 3, but Diablo 4 enables me to just talk and chill with you guys and even play a game with you, which I would love personally. But with all of that being said, what I'm going to go ahead and do is I am going to take you all into a quick reminder as to what is prompting me to get back into streaming for a little bit. We need your help. And I would like to do streaming more regularly now that my life has settled and I've gotten used to life with kids. I've had kids in the house now for almost a year now. Come May, it'll be a year. And honor mode multiplayer, oh my gosh. That sounds ridiculous and fun. And are you going to play with me, Panda? That sounds like something difficult for me to do. Anyways, let me get back into this. Let me talk about this real quick. So we have a GoFundMe up. This is in regards to a child who I have had the opportunity to take care of and whom we'd like to adopt into our family. Unfortunately, there are certain conditions and things that have happened inappropriately and illegally, might I add, that is preventing her contact with us, and her life is very much in a very fragile, jeopardized place, and she needs our help. So in order to prevent myself from saying something inappropriate, I am going to read the very filtered and very legally correct language here describing what's happening here, because I can't talk about as much as I'd like to talk about. I would love to give more details, but I cannot. This is because of privacy issues, confidentiality of the child, etc. But this is a sanitized version of what I am allowed to say. So here is what I will say. This is a fundraiser to help us fight for a child's right to safety and family. We're reaching out for support in an urgent legal battle to protect a vulnerable child who has been failed by the system. This child, who was once in our care and remains deeply loved by our family, has suffered mistreatment, neglect, and unnecessary separation from those who care for her most. From the moment she entered our lives, she made it clear she wanted to be part of our family. She calls us mom and dad and has repeatedly expressed her deep desire to belong with us permanently. Despite this, the system has ignored her wishes and placed barriers between us and her, denying her the stability, love, and security she deserves. Over the past year, we have fought tirelessly to ensure that she is safe, heard, and protected. Unfortunately, due to serious failures within the foster care system, she has endured documented abuse in placements that should have protected her. Despite overwhelming evidence, she was placed in harm's way, and now she has been cut off from us entirely without legal justification. A direct violation of her rights. We have secured legal representation and are taking action to challenge these decisions in court. Our goal is to restore her right to maintain safe, meaningful relationships with those who love and support her, to give her the opportunity to have her voice heard in court, to hold accountable those who fail to protect her, and ensure she has the chance to grow up in a stable, loving home, one she has already chosen. Now, naturally, legal battles of this nature are costly, and we cannot do this alone. Your donation will help cover attorney fees and legal filings to help fight for her right to family, expert testimony and court costs necessary to prove her case, and investigative resources to ensure her well-being is prioritized. Every dollar raised brings us one step closer to giving this child a home and the future she longs for. If you believe that every child deserves safety, love, and a voice in their own future, please consider donating and sharing this campaign. Thank you for standing with us in this fight for what is right. Your support means everything. There's a picture of us. Yes, that is the bicycle chicken outfit. She has a unicorn onesie, and then of course Tanantha has Chewbacca. I did put out an update today, just basically saying, hey, I'm trying to get the word out by doing these podcasts. I do want to make this a regular thing. I was already planning on making this a regular thing, so this gave me an awesome opportunity to kind of get some motivation to do it. And of course, with an update comes another picture. This time with Moogie Moo, my mom, and our child, and of course Tanantha. This is just wonderful to have, and this is what we're doing. We need to spread the word about this story. West Virginia is currently in a foster care crisis, very much a foster care crisis, and there's more than just one kid who needs help, right? There's a lot of children going through stuff like this that are not appropriately represented in court, that are not having their desires heard, that are being silenced for whatever reason. And I can't tell you the motivations or what I suspect the motivations are. That would be getting too detailed. But in short, what I can say is that this particular child, our daughter, needs our help. She wants to be with us, and her desires, though very well known, are not being honored, and she has a right to maintain contact with previous caregivers, and that right is being violated at the moment. We need to go to court in order to convince the court that we should be a party to the case, and that would give us the ability to help make decisions to steer her back home, and that is what we are trying to do. My hope is that by telling the story, other children can get the help that they need. Because if we're able to help this child, then that gives us the opportunity to tell people that, hey, this is what's happening. This is an important thing, and we need your help. So my sincere hope is that you would take a moment to donate if possible. We would very much appreciate any contribution. And if you can't contribute, then tell the story. Share the GoFundMe and tell somebody else, because the truth of the matter is that this is an overlooked problem, and in some parts of our country here in the United States, this is an all-out crisis mode where children don't even get what they need to get started. They need help. And I would appreciate it if you would take the time to share this. If you're a streamer, to share this with your streams. If you're just someone who can print out some flyers, there's actually a copy of a flyer in Discord general discussion that you could print out, and you could post it places. You could share the link on your socials. You could just talk to somebody. Let's just say, man, I heard about this story about this poor kid. That's fine. That the story needs to be told, because way too many children are going through this. And the only reason why our daughter is getting the help that she deserves is because, well, she came to us. And sadly, there's way too many people disillusioned and defeated by this system that when the child's out of the home, they're forgotten, they're left behind. And one of the things that I have noticed between every single child that's ever come into my home is they all love Lilo and Stitch. They love Lilo and Stitch, and they love Stitch because they relate to Stitch. And the reason why they relate to Stitch is because Stitch was this destructive creature that shows up and messes everything up. But Lilo said that he was adopted, and therefore he's part of the family, and family means no one gets left behind. This child is family to us, and we are not going to leave her behind, and we're not going to give up on her, and we're going to fight for her rights for as long as we can. And hopefully that means for the rest of her life as our daughter. In any particular case, that's what's going on. Your contribution is going to be incredibly helpful, and I'm thankful for you guys for providing what you have, whether it's by way of sharing or doing something along those lines. Thank you. I'll put a link to the chat one last time, and that will be that. And I think we did get a donation while I was talking about this. We did. Jason Stover, thank you so much for your very generous contribution of $100. I appreciate you. It means an awful lot to me. Very subdued stream compared to normal. Where normally we'd have like pancake dances and the whole nine, but honestly, we're here fighting for this young lady who definitely needs our help, and I'm just thankful that we've always had a community that's taking care of the least of these, the folk who need the help the most. If you can't contribute, like I said, not a big deal. I'm happy you heard the story, and I would ask that to help support us, to tell the story, to share the link, and to raise alarm bells around this situation, because it's not just her that's suffering. There's a lot of children who are unable to find stable homes, and even though there are parents who are willing and able to take them and support them, some for reasons I cannot specify, we are unable to do so. So thank you very much again for the help and support here. It's very much appreciated. All right, everybody, it snowed here. Normally at this part of the program, I'd be taking us to a game. I will start a stream later this evening, and we'll play the game then. Appreciate you, Tylerium. We'll play the game then. So I got to get up and I got to go shovel snow, and I want to have dinner with the kiddos and help them get to bed. So it'll probably be a later stream, and I haven't done an evening stream with you all yet. So I think that's what I'm going to do. I think I'm going to do an evening stream, and I don't know what I'm going to play yet. I haven't thought about it. I thought it was going to be Diablo IV, but man, all of a sudden Panda's got me thinking about Honor Mode Baldur's Gate 3, and I'm kind of like there. I feel like we're going to have a very short run. But either way, I'm excited to get into some type of game with you all. I haven't been gaming with you for a long time, and I kind of want to jump on it. So that would be a thing. In any particular, I don't know if I could do a multiplayer because my schedule is going to be all over the place. I cannot have a consistent schedule, just to make that very clear. Oh, that's an awesome piece of equipment right there. I cannot have a consistent schedule, so I think multiplayer is difficult for me to do. But anyways, thank you all so much for tuning in. Hopefully you all enjoyed the show, and yeah, y'all have a fantastic rest of your day. Hope I'll see you later on this evening. I will schedule the stream when I can, and then we'll act on it. But I got to go shovel snow now. So everybody have a good evening, and I'll see you around later this evening.